Modern AI assistants are very powerful nowadays, but there's one big limitation: they tend to forget crucial details between sessions. Every conversation almost starts fresh, as if the assistant has zero memory of what just happened before. But that's an issue Supermemory AI is built to solve. It gives your AI a persistent memory layer. Your app can store context, facts, and histories, and then later, when your model runs, it recalls all that context intelligently. In this video, we'll dive into how Supermemory works, when and how to use it, and you'll see how to build a little Supermemory chatbot application yourself. It's gonna be a lot of fun, so let's dive into it. So here's a high-level overview of how Supermemory works. You send it pieces of content, it can be text, files, chats, and Supermemory then indexes and embeds them into a semantic graph and groups them by entities like user, document, project. And at query time, it retrieves the most relevant memory chunks and injects them into your prompt for your LLM. And your AI assistant uses that context as though it had remembered those facts. This means your model doesn't have to carry all that prior context in the prompt. Instead, Supermemory handles its retrieval, ranking, and relevance. They have also modeled it to behave like an actual human brain would, with smart forgetting, decay, recency bias, and context rewriting. You can use Supermemory in 3 different ways: as an API, as an SDK, or as a memory router. If you use it as an API, you can interact with Supermemory as your own memory database. You can add memories, search, update, delete, and apply filters to them. This gives you a very fine-grained control over what goes in and how it's being retrieved. And if you're using frameworks like Vercel's AI SDK, Supermemory gives you a drop-in integration via the Supermemory Tools SDK package, and you can hook it up to stream text, generate text, or other SDK features. In this mode, Supermemory becomes a tool your agent carries. This removes a lot of the boilerplate. But if you already have an LLM setup, the memory router acts like a proxy. You can simply prepend your LLM's base URL with api.supermemory.ai/v3, and the router can handle chunking, token management, context injection, and retrieval behind the scenes. This is great for situations where you want memory without rewriting major parts of your architecture. All these 3 modes share the same memory pool when keyed by the same user or container ID, so you can also combine them if needed. So let's try it out for ourselves. For this demo, I'm going to be injecting Supermemory with data about BetterStack's YouTube channel statistics. I have already compiled a CSV file with all the videos BetterStack channel has produced, along with some interesting stats like views, number of likes, or comment count. And now I can simply drag and drop that file in Supermemory, and it will inject all my data and create memories out of it. We can see in the dashboard that it has this memory graph feature where you can explore how different memory nodes tie together and what are the common patterns and relationships between these different nodes. Next, I created this simple Next.js app with a chatbot, which calls a function that first creates a new OpenAI client. And here you can see that we are using the Supermemory proxy router strategy to proxy all our requests through Supermemory before sending it to the prompt. And here in the OpenAI configuration, I just have a simple instructions prompt to always fetch the memories from Supermemory. And for the provider, I am using GPT-4 in this example. It's also important to provide the relevant container tag in the user ID header, so Supermemory is able to bind that to the respective documents that were imported with that specific tag. And Supermemory has its own reasoning built into it, so it will try to intelligently find the best matches based on the contents of your prompt. And back in our app, we can see that the response output is now taking into account our channel's YouTube data. So every time I ask something related to our channel, it will be able to analyze all our channel data because it has all the context of our past YouTube videos. And what's even cooler is that you can give the chatbot some new information and it will store every message as a new memory. So when you access the memory graph, it is updating in real time with the new information you have just provided and trying to find links between different information nodes. So I hope this example demonstrates how you can build a deep knowledge base with Supermemory that are custom tailored to your data. This way you can also build custom AI agents who know your user preferences and your history, or coding agents that have a deep understanding of your code base. And Supermemory is cool because you don't need to reinvent embeddings, vector stores, or semantic indexing. Supermemory handles all of that on its own. And it also scales because memory operations are optimized. So there you have it. That is Supermemory in a nutshell. So what do you think about this tool? Have you tried it? Will you use it? Let us know in the comment section down below. And folks, if you like these types of technical breakdowns, let us know by clicking the like button underneath this video, and also don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.